explore now the VT graph. One more problem we'll take on VT graph. Let me take this 10 meters per second. This is 2, 4. Let this be 5. Let this be 10. Let me take it this till 7. And this will be let it be 4. Are you seeing some negative part of graph? So like, sorry, in the fourth quadrant is what we are having certain graph. Okay, this you try to notice. We'll shade different colors. This is let me shade it so that will be easy for you. No. Why this yellow? Okay, some rough shading is what I meant. Okay, let's see that. What is the x-axis? X-axis is t is in seconds. There's the velocity. And there's a time. So I want the average, like what is the distance covered, displacement, average velocity, also like a average velocity and average speed also for 0 to 7 seconds altogether. So first, these are areas are there, no? What do these areas will indicate? A1, A2 will calculate first magnitude of these areas. What is A1? A1 should be equal to of into base 2, it is 10. 10 it will be. What about A2? Here I'm asking you to look at here. Area of this yellow colored triangle. There's a triangle. Base is 2. Base is 2. Height is how much? 10. So half into base into height. Then area of this should be equal to like a rectangle it is. So 10 minus 4 minus 2. This will be 20. Area of this triangle. Height is 4. Base height is 1. So half into base 5 minus 4, height 4. That is 2. Last A4, area of triangle of into base, height is 4. There's a minus sign, no? Negative it is? No. So this will be minus 4, I'm getting. So what is this, like what do negative signs? If I ask you distance covered, so what we are going to do is like for distance covered. For distance covered, you have to just add up all the possible areas. So 10 plus 20 minus 2 mod of 30 plus 6, 36, I'll write it. So there's a total distance covered. What about displacement? You have to just take the algebraic sum of these. A1, 10, 20, minus 2, minus 4, 24 meter. Are you getting now? So this is the, like this, the area under the curve will see so much of information. Then what about average speed? Average speed. So what is average speed? Average speed should be equal to distance covered by total time taken. Distance covered is how much? 36, this one, meter per second. 36 by 7 meter per second. Average velocity. 24 by 7 meter per second. What do you mean by 24? This we didn't understood properly. Okay, let's plot the position versus time graph so that you'll understand little bit. Or how that motion occurs, how that actually motion takes place. We should get a better picture, no? So first what happened, it will move 10 meter, then it will move 20 meter. Then I'll extend further this line. It will move 10 meter for 2 seconds. The 10, I'll show it here. Then it will move another 20 meter. Then afterwards, it will move 2 meter, then 4 meter. Move 2 meter, then 4 meter. So this will be how much distance will be? 2 meters. And finally, it will come to rest. It started from rest. And finally, it is at rest. How the path is like this. Here the body will accelerate. A dash, I'll call it. Here V dash. Here it will move with a uniform speed, acceleration 0. Then what about the motion here? Here the speed will be in this direction. Here the speed will be in this direction. And it will undergo retardation. V1, Vx, I'll write it. VA, VB, VC. Some symbols I'll give it. Look at that, those arrows are very important. First, what will happen to the body? The velocity, the speed of object will increase. So accelerated motion, uniform velocity motion. Then again, this acceleration only. The speed is increasing. Then there's a retardation. So how the physically that motion occurs, the motion takes place like this. Accelerated, first accelerated, then uniform velocity, then it will take a turn, then acceleration, then retardation, then comes to rest. This is a path. What is this? This is a path. This is what you are seeing is a graph. The object is not moving like this here. Object just will go straight and returns back. Okay, now you have everything. So what is this 30 meter? There's a 30 meter plus 2 plus 4, how much? 36, agreed? Fine. Why 24 meter? Because this total distance is 30 meter. What about this 6 meter? Subtract that. So what do you get? You get the displacement. This is 30. This is 6. So total distance covered, how much it will be? 30 plus 6, distance covered. 30 minus 6, the displacement. So what's happening, body? It will move away from positive axis. Then again, it will start moving towards positive x-axis, towards origin. It will move away from origin, then towards origin. Can we plot position versus time graph? I think this will be really, really very important for student. They must develop from the beginning only. If you know one graph, how to plot the other one. Okay, I do have space. I'll try to accommodate here only. First, what is the type of motion? Uniform velocity motion. Little bit, yeah. See now. First, uniform for 2 seconds, uniform velocity motion. So for 2 seconds, it's a uniform velocity motion. Sorry, for 2 seconds, accelerated motion. Then uniform velocity motion for next another 2 seconds. Then it will undergo retardation. It will cover more distance. No? I'll increase the length of this. Plotting graphs without any skills, little bit difficult. 2 seconds. Yeah. Then what it will do? It will accelerate. And finally comes to rest. Okay, this is the time 2. This is 4. This is 5. This is 7. From the beginning only, student should develop this ability to plot the graphs. That's why I just included it here. All the respective things I'm showing it. Okay, agreed. So what is this? There's a position. There's a time. Now, what is that maximum distance? This should be equal to 30. Huh? I should indicate this to be 30. Agreed? The maximum what is the maximum distance of the object from the origin? 30 meters. Afterwards, it will start moving. Wait. The curve. This is a slight change. Yeah. So the final. Now, where I should indicate this should be the 24 meter. Because finally, where it is at a distance of 24 meter from the origin. Okay, this is a method of plotting of the graph. So here, accelerated motion, uniform velocity, accelerated motion along native x-axis, then returning motion along native x-axis. Nearby graph, I'll write it so that will be easy for you. So what is this? Accelerated motion along positive x-axis. I'll write it. It will be uniform velocity. This is AB. This is AC. Why I'm showing? Because related to that particular thing, the path. Or if you want accelerated motion along positive x-axis, what you should write here? Acceleration along positive x-axis. Acceleration along positive x-axis, uniform velocity, uniform speed. There's no problem. This is what, again, this also acceleration. Acceleration along negative x-axis it is. Retardation along positive x-axis. Okay, these are some examples like a VT graph. Also, we have so much of information in there, like OST graph, VT graph. So all both the graphs is what I'm showing. So from ST graph, we can show about acceleration retardation. From VT graph also, we can show acceleration retardation. Let me save this.